Welcome to my session regarding allowing customers or users to create personalized forms. And this is utilizing the new 4D objects. You guys might not know me. I'm kind of new at 4D. I started around 2.5 years ago, came out from SJSU. So my session is mainly about a proof of concept using 4D objects, the new 4D objects. This proof of concept proves that by using 4D objects, you can provide users a way to personalize their forms, not by using 4D, but after providing them the application in either like a compiled or a built application. So it's not them going in and developing it, but it's them customizing it after you've provided it for them. So I'm going to show you an example, a quick example of it. So view some records. So this is just an example of using an input-output form for viewing records. So here is, let me go to my tailor shop example. So this is for a tailor shop. So at a tailor shop, the users might be something like the receptionist, the tailor, and then other people. So a receptionist would like to see the information of the customer that's doing their tailoring. So valid data that they might want to see is the name, date, if they paid yet, how much it costs, their contact number, what time they're going to pick up their outfit. And then if you're a tailor, you might want something else. And this is using the same table. And this is the same form. This wasn't a recreated form. So by selecting the tailor, it automatically changes what is displayed, the color of the displays. You can just customize it however you like. So let me go get more into this. Oh. So what are the benefits of doing this? Well, there are many benefits of doing this. Mainly, it's user empowerment. By giving users the ability to customize their own forms, they feel more empowered. Don't you guys feel more empowered when you guys have more abilities, more features? That's why as 4D, we're always giving you more features, right? The more features, the better. And by allowing them to customize the display of their forms, it can also help with visual impairments, like some people are colorblind. Some people can't see blue well, some people can't see red well, so maybe they might want to change the colors. Or I see a lot of you are wearing glasses. Maybe some of you are nearsighted, some of you are farsighted. Some might like larger font, smaller font. So by allowing them to customize the size, the color, the display of their form, it also helps out the users a lot. So let's get into some small background information. I believe you guys might already know most of this stuff, so this will be short and quick, but it's mainly about two things in 4D. The objects in 4D. So back then, before, you know that form objects. This was the main type of object of 4D, pre-14R, whatever, where the language objects came out. This is like the variable objects where you drag onto the form, the list boxes, all those objects. Those were the only objects that you mainly thought of when talking about objects in 4D back then. So you guys are familiar with this. Now, the new cool kids on the block, the language objects. This gives you so much more ability to do stuff in 4D because of how flexible it is and how it can contain so many types of data. As I said, this was introduced in around V14, but then in V15, it has also become a field data type, so you can add it to a table as its own field. And when using language objects, the form objects used to use object family of commands. So when you were using the form objects, the commands would typically start with object get, object set. Yeah, you guys know that. With the language objects, they use the OB family. So it's OB space set, ob space get. And yeah, that kind of makes it easier to understand when coding. And language objects, as you may have been told a couple times already, use what is following the JSON format of the name-value pair. So you name the property or the key, and then you also provide a value with that name. So regarding the scope of this proof of concept, I just wanted to create a simple input-output form for viewing records, and then allow users to customize how they view the specific records. And yeah, it's not something too complex. It's just providing a proof of concept so you guys can see that if you guys like it, you guys can develop it, make it more better, and yeah. So for my design, I started off with the form object definition. So as you know, the form has multiple objects on it. And then these objects have definitions. And that's what makes them, gives them their size, their properties, what they look like. And what are these form definitions? They are listed in the property list as such. This is a sample of the definitions for a form object. You guys might have seen this multiple times when developing your applications. As you can see, they all, each property has a name and then a value. And by looking at this, it kind of clicked in my mind, oh, name, value, isn't that a name-value pair? Where did I just hear this? I heard this with the JSON, the new JSON language object. So then by thinking about that, I was able to figure out that you could just save these properties to an object, a language object, and then read and set those the variable to define the objects. And here's a sample of how it would look like. So on the left is the object, the language object, and on the right is the properties. So the name would be type, the property is variable. The name would be object name, type would be variable. And then you can even have numbers. Numbers are in quotes in the format. And then true and false is also allowed in this new language object. So next was creating the structure of the definition. So this is where you can do it yourself. You don't have to follow my exact structure, but how I did it was I put everything inside a single language object, a single variable, so then it can all be loaded into one variable, all extracted from one variable, so it's quick to read, quick to save. And then for the main object, it has the general properties of the form. And then it also contains an array. And then in that array is the properties of each of the fields of the table that I'm presenting, because I'm presenting the detailed form from a record. We can take a look at how it looks like. So yeah, so basically I saved, this is a .json just to format it nicely, but this is for table 4. The font family was set to Calgary. The font size is 24, font style, color, default settings, and here are the fields. So as I said, it also contains an array of objects. This is what makes objects so flexible when containing data. It can also contain an array of itself and nest in more objects in it. So for the field, I have one for the ID, and then I list the properties of how to display that variable object. And then you can also do height, placeholder, entry filter. Here's field 2, field 3, and field 4. You can get the idea of how I'm formatting the structure of my JSON. So then, so that's how the structure of my definition was for my for doing the dynamic form. And then generating the definition was easier. So after I had the structure, you just create the variable object, or the variable for the object, and then you just load it with the new ob set commands. So ob set, if I wanted to name it the name something, then it would be ob set, and then the property name, and then the property itself. It's a easy command to learn. And so for the demo that I provided, since it needs to load a JSON to load the table, it has a default setting. So my default settings, I just set it to mimic what it would look like for how 4D would generate a default input-output forms. But then when a user customizes the values, every time you customize a property, it would go in and reset that property. So if I'm changing the height of a variable, it would go, depending on which variable or which field I'm setting, it would just go ob set and then go into that object and set it to the new value. And it's pretty easy with that single object variable that I was talking about earlier. So storing the definition was a little bit more kind of iffy on how to think about it. There are many ways to do this. As I said, I stored it in a single object file, but then you can store it inside your database, but I decided to just store it outside of the database. So then when a user has their own customized formats, they don't want to download the new updated version and have it all replaced. So that's how my thought process worked. So maybe you could set it to save in their documents folder or some location where it wouldn't get overwritten, but it would stay saved. And then I saved it as a .json file since it's using that JSON name pair format. But for my demo, I saved it in the resources folder so that I wouldn't take up your guys' hard drive space if you guys want to delete it or something, and not create multiple JSON files on your desktop without you guys knowing. So yeah, so I put it in the resources folder, but I don't think that's such a good place for the actual application of this type of implementation. So the storage of the definition, I stored it using a naming system so that I could find the specific files, because as you saw earlier, a single table can have multiple formats in for one table. There was that one table 4 had the receptionist format, the customized of the base tailored to the receptionist, and one for the tailor themselves. So because there are multiple customizable saved formats for a single table, I set up a naming system so that it would use the table numbers, and that would use the customizable name or the user-defined names for the formats. And each file would contain its own single large object, but those objects can contain multiple information. So reading the definition basically works in reverse. You start by locating the folder where the expected files are stored. And then you take the files and then you just load them onto 4D using open document, and then text to JSON, and then you store it into the object. And then once it's in the object variable, you can just use obget to get all the properties you need, and then you apply it to the objects on the form. And here's a graphical representation. So you go into the folder, 4D goes into a folder. It searches through the folder for the specific JSONs. As I said, for my demo, I prefixed it with the number of the table for easy access. So if I'm going to table 4, it'll only locate those 3, and then it will list those 3, and then you can select the specific one you want, the default one, which I have created from the application. Because it needs a default one to load. Without any definitions, you would just have a blank page. you need definitions. And then there's also the receptionist and the tailor, which I showed you guys earlier. And then there are also tables 1 to 3. And then those get loaded into the form object. And then 40 can load them and display the forms. So to apply the definition, first, my proof of concept just applies the general properties. I set it up so that the text labels all use the same properties. I found it kind of awkward to like make the text, each text display a different size and shape. I felt that the variable objects were more likely to be changed, while it's better to just keep the text labels the same size, because maybe you want some numbers a different color or some numbers larger than the others, like I said earlier. But if you also change around the labels, it kind of makes it look all not nice. So that's why earlier you saw in the JSON example, there were the general properties listed at the top, and that for each field there were specific properties, and those specific properties for the fields were actually for the variable objects, while the top definitions were for the text variables. So here's an example of how easy it is to apply the definition. So right there you see it's the font family is Calvary. So we use the object set font command. As I said, the objects on the forms use the object set of families, and that's how they work. So I just object set font, find the object name, and then set it to Calvary. For the font size, it's a similar fashion. Object set font size, object name, and then the size. And then you can even do placeholder, filters, enterable. 40 has provided so much control features for your objects and such. So it's pretty easy to just find the command you need to apply the definition. So for the implementation, now we're going to get a little bit more like specific into the technical aspects of the demo. This is more based on the demo and isn't more proof of concept, but you can see how my thought process went. It starts with a table subform. The table subform is needed because a subform is a good object to use when you have something that's a variable in size, because if you have a form, but you don't know how many objects you're going to stick onto it, if you extend an object beyond the size of the form, it will disappear. Maybe you guys might have seen that. Have you guys worked with duplicate object before? And then maybe set it outside of the scope of your form? If you haven't and you've done that, then that object kind of disappears or things get kind of glitchy. But with a subform, what's good about it when working outside of the space of the set size, the subform automatically applies scrolls because it's a small object on a main form. And with those scrolls, you can allow the customer or the user to maybe go from a size 12 font and set everything to like a size 50 font. And none of the objects will disappear. It just will be a tiny little screen, but they have the scroll bars to scroll to where to scroll and see all the objects on their forms. And then for the table subform, I needed to use the object duplicate for this because I'm using the same form to work with multiple tables and also multiple configurations that the customer might like. So let me go back to my demo and show that. So here are four different tables, but all these are all, working on the same form. When I click on 2, it reloads everything from that table. So let me show you what. Structure is. So here, so these are the fields for table 2, fields for table 3, fields for table 4. And then if I go to that, Sorry about this. Let me just reopen it. So yeah, so those 4 forms are all listed. I mean, all those 4 tables are all listed here. When I go to 2, there are only 5 objects for the 5 fields before. When I go to table 3, all those objects are shown. When I go to the tailor shop table, all these are shown. And here's the scroll that I was talking about. So because it went larger, I'm not sure what's extending over there, maybe some space or something. But yeah, because it went larger, you can scroll. But if you go smaller, then it doesn't need the scrolls, as explained. And then the table has only, this configuration only uses 8 objects, while this configuration uses lists 8 different objects. But this configuration only has 5. So I use the object duplicate a lot to reload this. And to apply the reload, I use the on-bound variable change for subforms, which is a pretty good trigger. It's a trigger for the form. Basically, when you set the subform to a new value, it will activate that trigger. So if form event equals on-bound variable change, it will trigger the change. So this is how it basically loads it. So first, it loads the title or the label, and then the object title, label, object. And that's how it basically builds it in a slower format from reading the JSON file. So it applies all the general properties to the text label first. And then it duplicates the default. You have to place default objects to get duplicated. So that's kind of a limitation of 4D right now. You can't really just create an object on the fly. You have to provide that form with the base objects to duplicate it off of. Then duplicating that object, you can duplicate as many as you want. So there's a sort of limitation there where you have to place the objects first, but it's still pretty, yes?
Can you create one form that's inherited by all other forms that has the objects already created on it so that then can then be used so that you don't have to do that for every single form?
Yeah, that's what I basically just said. So this, yeah. Yeah, it's mainly code-based. I just have one subform, and that subform, as I showed earlier, can represent the whole 4 tables. And it can also, for each of those tables, you can have multiple customizable formats, like I showed, one for the tailor and one for the receptionist. And this is all being, all of those configurations were loaded from one subform. So yeah, so the subform, and then after it loads the text, it duplicates the variable object, and then it applies the properties defined in the object that we set to it, and then it does it for each field that we are displaying for the table. Let me show you. So yeah, let me. So yeah, so this is the subform right here. These are the 4 objects that I needed to set for it, and that's it. This whole subform is the thing that's loading everything. And if you want to, the table subform is just that right there. Okay, it's just. Yeah, I just put on. Yeah. Which in itself is yeah. Yeah, and that's done by the on-bound variable change trigger right there. So when that happens, when that happens, you get the on-bound variable change. And then first I check if the default value needs to be loaded, if basically it can't find the JSON file. And if it is, then I'll set this default value to true, and then it'll generate a default version of the form. But then if there is, then it'll grab the object, which we loaded with the definitions in the .json file, into an object language. And then it will basically read it and set it all into there. So basically here is where the C, the language object is read. And then right here, it sets all the base, basically all the objects will start with base. You want to set them all to invisible. So basically every time you load the object, reload the subforms, all the objects that were duplicated are still on that form. So to prevent a memory leak of sorts, you don't want to continuously duplicate more of those objects, but instead you want to reuse them. So basically, if I have 8 text labels, I'll have base text 1, base text 2, all the way to 8. And then if I'm reloading a new format, I don't want to add on 9 to 16. I want to reuse those 1 to 8. So first, I set everything to invisible, just in case I'm going to another format that only has 5 text labels. And then I set all the coordinates to 0, 0, because if you have a text label at like maybe 500 something, and you'll have the scroll. But if you only need to display 2 objects, why is the scroll sending you all the way to the bottom of the subform? So that's why I set them to 0, 0. And then right here, you grab the style and the base formats from the JSON object, that such as the family, size, and such. You get the arrays for the fields. And here is where you check if you need to be duplicated. So as I said, you want to reuse. So for, you have a semi-global counter that knows how many of the objects you have. And if the counter is increased to you have a global number that is saving how many of those fields have been created on the form. Then as you go through the definition, you'll be counting. So I'm on the first text label. The count is 1. And then it'll check if I already have a 1 text label to use. If I do, then it'll just skip this. If not, then I use the object duplicate command to duplicate it. And I set the name to the number, so it'll be base text 1. And then I increase the count if a new one was duplicated. If not, then we simply just go, set the title of the object to the correct name, set the coordinates based on how you want to format it, set that object to visible because we set everything to invisible earlier. We then go ahead and grab the field object because the field object is a field array. We want the correct array. And then you can set the, start applying the definitions to the variable that's being displayed, such as placeholder, filter, and such. Here's base picture, and that's how the definition is applied to the subform. And let me show you guys how the customer can customize their objects, or the user. So here, let me go to, and this also uses the same subform to, on the fly, show them a feedback of what their customizations are doing. So I think it's pretty neat that we can reuse that same subtable form that we created, mainly to allow them to customize their displays. And we can also reuse it in another form to show them their feedback on what their changes are doing, but not exactly saving their changes yet, so then they can know what they're doing. And that's how object-oriented programming works. We like to reuse stuff. We don't want to reinvent stuff. So let me do something like change these to bold, or underline them. They all got underlined. maybe italicize it. It's all italicized. Bold it. Maybe we want a different color since we don't like the color blue. Let's go something like green or something. Yeah. And then you can also order the fields. So right now I have ID at the top. Maybe I want ID to be at the bottom. So I can do something like this. Oh, ID is now at the bottom. Maybe dates. Maybe I want to put the notes at the top so then I can read the notes earlier. So the notes are at the top. And then you can also format the fields. So let's do something like the name. Maybe I don't want to care what the customer's name is. I just want their money. I'll just hide their name. And then, yeah, and then maybe like I said, I want to know more about how much they paid or not. So I go to here and maybe make this a larger size, something like 40 and such like that. Oh, there's some spacing issues there. Let me change it to a radio button type. Checkbox. So you can even change it checkbox or radio button. You can do a lot. And then if you want to save it, I just did this so I can name this 40 Summit. And then I save it. And it's saved. It got saved into the resources right there. So that's the one I just created right now. And then if I want to, I can even overwrite it, overwrite the same one with a different one. Maybe I want to change the color to red. And then if I save it, it will it will let me know that the file already existed, and then if I'd like to overwrite it, so I can. And then if I go back to the Explorer, go back to the main and load this again, then I go to the tailor shop, it should have the one that we just created right there. And how I created this so that which configuration it loads, it basically loads based on the last modified property of the file. And when you select an object, it resaves that file basically, just to update that last modified so it knows which one the customer last used. So since I selected receptionist, it automatically resaves that receptionist with the exact same contents. And because of that, it updates the file's last modified date. And by using document get properties, you can load back up that last modified date and know which one to load. So if I go back to Taylor and then I close this and I open it back up again, it should give me the Taylor format when I go to the correct table. Or, did I? Okay. Okay, I think this one didn't. I didn't do it for this one correctly, but yeah, that's how it should have worked. Okay.